Hello, and welcome to section 5.5, which is called Functions as Models. And this section, I just want to warn you, it's kind of a weird section. It covers a bunch of different topics, and I'm not actually going to cover all of them, and you're not going to get all the different types of questions in the homework. So there's a couple things I'm skipping. But the two things we are going to cover is, first of all, we're going to talk about absolute value and the relationship between absolute value and distance on a number line. And we're also going to talk about the shapes of graphs and how they can be curved in different ways and how that comes out when we talk about slopes. So that's going to be in a couple more videos. But I just want to let you know that because there are going to be some things in the book that we're skipping. So if you're studying for the test by just reading the book, you might want to keep that in mind. The notes here might be a better guide. And remember that you can always get these notes from the Dropbox link on the Canvas page. All of these PDFs you can download and look at them later if you're not taking perfectly great notes. Anyways, so first of all, let's think about the number line and just distance. And this first question is one for you to do. Name two values of x that make this sentence here true. Make it so the distance from x to 7 is 4 units. That's just the distance on the number line. So it should be pretty quick. You can pause it here to copy stuff down because in a moment I'll show you the answer. Okay, so we got x equals 3, x equals 11. Those are the 2 points that are 4 units away from 7 on the number line. So you can go in either direction, whether you're going to the left or to the right, it's still a distance of 4 units. Okay, so now let's see what that has to do with absolute value. Here's another quick exercise for you to do. Just evaluate each of these two expressions, the absolute value of 11 minus 7 and the absolute value of 3 minus 7. And you can pause it for a moment. Both of these give you 4. And when you think of subtraction, like what does 11 minus 7 mean? When you first learned about how to subtract in elementary school, you probably thought about it as like the difference between two numbers. How far apart are they? But the problem is that sometimes it becomes negative. So, for example, if you do 3 minus 7, because the 7's bigger, you get negative 4. But the absolute value will take that negative 4 and force it to be positive. So this one still gives you the distance between 3 and 7, which is 4 units. And the distance from 11 to 7 is also 4 units. So they come out the same thing, as the same thing. So this is really the moral of the story here. This expression, the absolute value of something minus something else, the absolute value of x minus a, results in the distance from x to a on a number line. And so you can see how that worked here. If our x was 11 or 3 and the a is 7, these two expressions both resulted in the distance from x to 7, whichever direction you go. So you can sort of see how that would work in general. Let's do an example now of using that fact to solve some weird kinds of equations. So this is a thing that comes up a lot in the sciences when you want to talk about like how far a number is from another number, whether you go left or right. So it's actually a thing that comes up a lot in statistics and in different kinds of science classes. So understanding how to go between the mathematical equations or inequalities like these, there's actually a few more here, and write it in English or see what it looks like as a picture it's a useful skill. So you might get the idea after I just do a couple of these. I'll work out a few of them, and at any point I always recommend just like pausing the video and try to work out the rest on your own if you can. You'll always learn more that way if you try it first. than if you just wait for me to do it for you. So we're going to use this important fact to translate a thing about absolute value into English, and an English thing about distance. So for A first, the first thing I want to realize is the absolute value of x is also, you can think of that as just x minus 0. It's the same thing, x is just the same thing as x minus 0. And if you write it that way, you can see that that means the distance from x to 0. And you might remember from back in section 5.3, we defined the absolute value of x as just the distance from x to 0 in the first place. So yeah, that's the way I would write this. The distance from x to 0 is 3.7. And this is one way to, you can talk about distance in English, but you could also do it without actually using the word distance, which is kind of more common. You could also say x is 3.7 units from 0. It means the same thing. So let's draw a picture of that on a number line here. We got 0, and we can either go 3.7 units that way, or we can go 3.7 units that way. If we go to the right, we get to positive 3.7. And if we go to the left, we get to negative 3.7. So the solution is just x equals plus or minus 3.7. Those are the two things that x can be that will make this true. Okay, let's look at B next. So first, just using the rule, the absolute value of x minus 10, the left side of this represents the distance from x to 10. The equals, you could say just equals, you could just write out the word equals, or usually it's more common to write the word is for equals because it's a more common word in English. And what is that distance? It is 2. So you could write it that way. You could also say the other way without actually using the word distance. X is 2 units from 10. It means the same thing. So when we draw a picture of that, we're going to have 10 somewhere over here. It doesn't really matter where you draw it. And we want to say x is 2 units to the left, or x could be 2 units to the right. That puts you at either 8 or 12. And so the solution is x equals 8 or x equals 12. And of course, it is always a good idea to plug these in to the equation. If you plug in x equals 8, you'll get the absolute value of negative 2 is equal to 2, and that works. And also, if you plug in 12, you'll get 12 minus 10 is 2, and the absolute value of 2 is 2. So that one works too. Let's look at C. I'm going to make a little bit of room here. So this is not written as x minus 2. If it was x minus 2, it would be the distance from x to 2, because it really has to be minus here for this to work. So how could we write this as x minus something? Well, x plus 2 is the same thing as x minus negative 2. X minus negative 2 is the same thing as x plus 2. So that way this is now written as an equation that's directly about distance. It is the distance from x to negative 2. So yeah, that distance from x to negative 2 is 0.5, and you can also say x is 0.5 units from negative 2. So if we draw a picture of that, here's negative 2. We want to go, we can go in either direction a distance of 0.5 units to get to x. So you can go 0.5 units to the right, or you can go 0.5 units to the left. If you go to this point, you're halfway between -2 and 3. And if you go to this one, you're halfway between -1 and -2. So the solutions are x equals -2.5. That's the one that's half of a unit that way. Or x equals -1.5. That's the one that's halfway between -1 and -2. Okay, now let's talk about inequalities here. So the same thing still applies. The absolute value of x minus a number still represents the distance from x to that number. So let's write this out, but just instead of saying it is 2, this means is less than 2. Here that is written out. The thing on the left represents the distance from x to 10, and that must be less than 2. You could also write this in the other form, like so. X is less than 2 units from 10. And let's draw a picture of that. Let's say you've got 10 over here, and you know if you go 2 to the left, you'll get to 8. If you go 2 units up here, you'll get to 12. So what are the things here that x can be? If we want to solve this, we want to see what values of x make this true. What values of x make the distance from x to 10 less than 2 units? So those are all going to be the ones that are closer than that. So you could shade it in the number line like that, or if you're doing it with a regular pen, you just include an open circle because 8 is not actually a solution, and then shade all of this stuff until you get up to 12, and then an open circle there. So why is 12 and 8 not a solution? Because if you plug in 12, for example, you'll get 2 on the left side, and 2 is not less than 2. So you could write the solution set here in interval form. You could write it as the interval from 8 to 12, or you could just write it as x is greater than 8 and x is less than 12. Either of those are fine answers. Let's look at E. We know the expression on the left means the distance from x to 10. But how do you say, you could say is greater or equal to 0.1? That sounds a little awkward. It's more common in English to write this greater or equal is usually written as at least 0.1. So that means the same thing. You could also say x is at least 0.1 units from 10. Those mean the same thing. So what does that look like on a number line? Let's see. Let's put 10 somewhere in the middle here. And if you go 0.1 units to the right, you'll get to this point, which is 10.1. And if you start at 10 and you go 0.1 units to the left, just a little bit, you'll get to this point, which is 9.9 right there. And we want the distance to be more than, further away than these points are from 10. So if we're going to shade that in here, that would represent, it would include 10.1 itself because it's greater or equal to. So at least or greater or equal to means that actual value count. So I'm going to make a solid dot there and shade in all this stuff. And then you could also go the other way to get all those things. So you could write the solution as x is less than or equal to 9.9. That would mean you're at least 0.1 units to the left. It could also be true that x is greater or equal to 10.1, if you're at least 0.1, if x is at least 0.1 units to the right on the other side. Now, if you write this in interval notation, you got to remember that negative infinity is the thing all the way out to the left, and infinity is the thing all the way out to the right. So you could write this interval as negative infinity to 9.9, including the 9.9, union with the interval from 10.1, including 10.1, up to infinity on the right. How about this one? The absolute value of x minus 10 is at least negative 7. Or sorry, it is greater than negative 7, not quite at least. So to just write this in English, the distance from x to 10 is greater than negative 7. If we draw this on a number line, here's a line, sort of. Let's say here's 10. If you take any point, any value of x, and plug it into this, you're going to get a positive result on the left side. Or you might get 0. If you plug in 10 itself, 10 is the point where if you plug in x equals 10, that's the smallest possible distance to 10. So that'll give you 10 minus 10 is 0 when x is 10, and 0 is greater than negative 7. So that works. And if you plug in any other point, anywhere, you're going to get a positive number for the distance. So the solution to this is all real numbers. X can be anything, and because the distance from x to 10 is always positive, or maybe 0 if x is 10, then you will get a positive result on the left side, which is always greater than negative 7. So we can say the solution is all real numbers. And you can also write that as the interval from negative infinity to infinity. All right, this video was long. Sorry about that. Hopefully it was, I was going a little bit slower this time, so it shouldn't be too painful. Hopefully this didn't take forever. Here's the exercise for you to do. This is pretty similar to what we just did. Your goal is to translate this into absolute value notation and then draw the picture on a number line. So it's kind of like what we just did, but it's going backwards a little bit. So good luck with that. Thanks for sitting through this video, and they'll try to keep the next one a little shorter.